Hello, good morning. Welcome to another episode of Sound Talk Show. So we're gonna do Wolfram language coding, advent of code, we're gonna do where is it? Let's see. Okay, let's go to Emacs show advent of code, 2023, day 14, part 2. This is take 4. We are going to continue to do some, find the periodicy of a function nesting sequence. And let's begin. Advent of code, Wolfram language. How are you guys? And but I want to show you some of the fantastic things I have been doing. By the way, this image is generated by AI, artificial intelligence. We did a talk show about it about 2 months ago. Wolfram language. So I have written this plain tiling package. I did a few live stream about it. It's fantastic in Wolfram language. It's about plain tiling. So this package, you can use it. You can generate any type of periodic patterns or tilings. So it's on GitHub, free. You can download it on GitHub right there. Okay, and there's this guy. Who did great work with the package. This what's his name? He's got a Sandoval, correct? Something. He's got a website, so it's Spanish. You can check it out. But let me show you. So some of the great, beautiful things he sent me. See, can you see it? Yes. Okay. See, then this math formulas, geometry, lots of square roots and stuff, and then you generate this. Now, how exactly are the curves? Let's see. How does he generate the curve? Convert circle to line. Fundamental region, fundamental domain. Okay, so first of all, in order to create these graphics, the most important thing is to create this curve. So how does he create the curve? Convert circle to line. Join form, cap form, round, circle. So this part, I'm not sure. You have to look into. So what is convert circle to line? That's a function I wrote, I think. I don't remember. It's, I wrote this package like almost 30 years ago. And I have just updated it a few months ago. But okay, so I need to load the package. So let's load the package. Advent of code, so I need to load the package. Here is the package, okay? Plain tiling documentation, there it is. So you load the package. Now it's loaded. Now let's go back here. Let's see what is the if you are watching this offline, skip around, okay? This is old. Control C copy. I think that's the old package. Question mark, paste it. Oh, there it is. Convert all circle graphics primitive to line. Yeah. So where is it defined? It is defined. Yeah, it's defined in my package. So anyway, so let's see. Very pretty. But still, we haven't found out how exactly are the curves generated. So let's go back. Let's go here. Okay, let's evaluate this. Control and Shift Enter. Okay, convert circle to line. So you got a circle. So this is fundamental domain plate, cap form, join form, line, convert to circle. Arc cosine, there it is. So part of it is arc cosine. So basically you got this, then bunch of lines, line segments based from a circle. So part of it is a circle and part of it is arc cosine. You got a circle, arc cosine there again. Yeah. So yeah, so I guess, so this part is a circle, then that part is arc cosine. Arc cosine, yeah, I guess so. And maybe that part as well. So you get this beautiful. Then the next, so basically the fundamental region is this one. You want to generate that. Then you just use rosette motif that will just repeat it into a like a symmetric rotational symmetry pattern. Then you so you create a new fundamental domain region, and what do? You use the original, then you add this bunch of lines. Okay, 1 line, 2 line, 3, 4, 5, then more circles, and then you add more circles, then more arc cosine. Yeah, so you want to generate, you want to turn a line into a strip. Now, is there no simple function to turn a line into a strip? I'm not sure. So then eventually you generate this beautiful. Then you remove the internal line, then you generate this. Now, but here's a question. How do you remove the edge crossings? How did he do that? Let's see. So does he, how do you remove? Okay, I guess you just manually code it. You see, in this bunch of code, you don't have the edge crossings. Oh, then you actually, so this is interesting. Then you actually weave it. You see, once you got this pattern, you want it weaved, because weaved, when you have it weaved, it's more beautiful. You see, now you got this. It's more intricate. It's kind of like the Celtic patterns. So fantastic. So what is the difference between this one and the next one? I'm not sure. Beautiful. That's that one. So what about here? Here's another one. And this one, you see, this one is a tiling. It looks like that. So you start with this, you build this fundamental region. Yeah, so you begin simple with lines. Then you can generate this tiling pattern. Then you refine it by turning lines into strips. Then you got this pattern. Then you remove the initial lines. Then you got this pattern. It's beautiful. So go down, then what do? Then you start to weave it. Then you create, remove certain lines so they cross each other. Then you got this pattern. This is like Islamic styled pattern. Wow, that's beautiful. Truly beautiful. Then what do? Then you what is the difference of this one? If you are here, say hi. If you are watching this offline, skip around and play at 1.5 speed. So what is this one versus this one? Oh, it reversed, it flipped the fundamental region. So does it reverse the yes, it kind of reverse like a mirror image. Fantastic. Okay, so now let's do the advent of code. So I want to continue the advent of code. So last time we need to finish this code. Yep. Okay, this is today, and let's put the code here. Okay, let's start to code. So here is a function of mod over 5, and here's a table. Let's see if we can, yeah, we can do that. Let's evaluate the region. So here's the output. Here's the output of this function mod, mod 5. Okay, then we discussed periodicy. Then then go down, find cyclic tail. This is interesting function because given a list, it will return the repeating tail. So so if we run that, let's get some example. Run it. So yeah, so the input, if the input is 93232, you get 32. Okay, copy that. So let's put here. Yeah, okay. Okay, that's that function. Then the function we really want to write is get this this one, get period. In fact, this should be named get nested period. So you want, so this function takes a function and initial value and the maximal number of nesting, and it will return a periodicy of the function, like the function applied to the initial value, get output and feed back to the function, get output and feed it back to the function, repeat until you find a repeating periodicy, like 1 2 3 1 2 3. So then this function will report the periodicy. Okay, so this function should be named not get period but get nest period. So something like that. Okay. Okay, get nest period, and okay, and this function is not finished last time, so let's finish it now. Hello, Kuha, Wolfram language. Didn't you see the YouTube title, Wolfram language? So we want to write this function. So first of all, we define a module. Module means a variable block. So we have a local variable ftest. But basically we want to call nest while. So nest while is a function that will take a function and initial value and the test function. It will simply nest the function until your test function returns false. Okay. So that's nest while. So we call that give the function initial value and give the test function. Then this all means feed the test function all previous results. Okay. Then max nest is the maximum number of recursion we want to do, because we do not know the function repeat or not. It may be a function when you nest it does not repeat. So we need to have a maximum value. Otherwise, it's infinite computation. So the interesting part is this ftest function. So the ftest function basically we'll call this find cyclic tail. Okay. Evaluated at # means all the arguments. So we can see here is a function. Okay, and the function body is just if statement. So, and where's the function argument? Argument is represented by the # sign. That means all arguments. So this braces # sign means is the braces # sign is just a list of all the arguments. So this is a list, and you pass this list to find cyclic trail. So that determines if the last, if the result is a repeating with a repeating tail. Now, if that returns an empty list, then return true. True means continue the nesting. So otherwise, return false. Return false means stop the nesting. So this nest while, so it will stop. But every time you call this, let's see, you see this function is meant to find the period. So you don't want, so nest while simply return the last result of the nesting. But what you really want is to find the period, okay? So what do you have to do? So yeah, so let's see if there's an option that allows you to return something. Return the result found when f had been applied n fewer times. Okay, so apply f extra n times. You want to return nest while interesting. So nest while takes a function, and basically according to this documentation, the nest while will always return an output of the function. It always returns the output of the function, okay? So, but our function get nest period should return a period. So we need to do something here. So this nest while is actually just a byproduct. That's right. We don't actually care about the output of the function. We just want to run the code so that we can see whether it repeats or not. So this nest while is actually a byproduct. Okay, so that shouldn't be the result. The result would be so if, let's see, find cyclic tail. If it's true, if it's empty, repeat. Otherwise return false. But you need to let's say something temp result. Okay, so otherwise temp result equals to the input, and so this is breaking pure functional programming because you are setting a value. Yeah, but let's just get it to work first. Okay, so if there is no cyclic tail, then you return true. That means continue the nesting. Now if you found the cyclic tail, okay, you need to temporarily save the cyclic tail, exactly what's their value. That's right. So okay, so we need to modify this function. Okay, so let me show you how to do that. We write again module here. So we write the module, put this whole thing here. That's a function body. That means the module body. Module is a local variable block, and so let's call this x result. Okay, temp. This is a local variable. So what you want to do is you want to, oh wait, actually you need to put the module inside the function. Okay, not, so you need to put the module inside the function. So here, so cut that, paste it here. Okay, so you got a function, and inside the function is a module. Okay, let me just code it. Well, actually, why don't you put the function there? Let me just code it. Okay. Function yeah, how does this work? So you want Well, the thing is the test function. Well, the test function is called by this nest while. So let's think about this. So you are nesting a function. Here you are nesting a function. You do not actually care about the function's result, but rather you just want to know the periodicy of the function when it's nested. And so you do need to nest the function, because you need the function's value to determine the periodicy. So this is a byproduct. So when we do nest while, but we also need to have a test, this test will determine whether to stop or not. Okay, so right now we are trying to define this test. So basically, so the test is a function. The test must be a function. That's right. Okay, that resolves that. Okay, the test actually needs to be a function. So remove that. So the test needs to be a function. Then inside the function, we need some kind of temporary variable. Okay, so let's use a module for it. Okay, and inside the module, should we use module or block? Module is lexical scoping, but it's fairly slow, because every time you call a module, every variable, it will just generate a new variable, new symbol. So generating a new symbol is slow. In fact, it generates a unique symbol. And the way Wolfram language does that is it appends a number, incremental number, to each variable name, whatever variable. So it has to internally keep count. So when you use module, so basically it means it's relatively very slow. You could use dynamic scope, so block, or you can use a constant. Should you use a constant? Let's see. What we need the variable for is that we need to store the result of this cyclic tail, so that we can get the length and find the period. So what equals to, so let's do that there. That will temporarily save the result. Okay, then if the result is empty, return true, continue running. Otherwise, return false, stop the loop. Okay, and okay, but however, you see the result, we need to, right now this result is local. We need to save it, so that we can get the length of return, the length of the result. This is the actual thing we want, the periodicy. So over there, let's see. So put a comma. Comma means suppress the output. Well, the comma syntax, the semicolon syntax actually means, in Lisp, it's like prog. So whenever you have a semicolon, it actually just turns the whole expression into compound expression. Bracket, then several expression. It's like the Lisp's PROGN. So anyway, so we nest it. Every time you nest it, you call this test function. So let's rename it, okay? Test function. Okay, then okay, so let's remove these. Okay, so you define a test function to be a function, and oh, you don't actually want the module. Yeah, so don't do the yeah, that's right. So you don't want this result to be local. You directly save it to there. Okay, so this module thing, yeah, remove that. That's right. And then and you don't need the curly braces. So this line directly save this tail to the result. Then if the result is empty, then return true. Now I want to check if SameQ returns if that is true. Okay, eval line true. Okay, so it's able to determine two empty braces are equal. These are kind of tricky because testing equality is one of the most complicated thing in programming languages, and that is because like for example in proof theory, in type theory, testing equality is the most complex thing because you cannot because for example integer 3 and 3 is equal for sure, but when you have an empty list, maybe you are checking the reference of that array, or you are checking something else, or or if you have like 3.0 versus 3 integer, intuitively we want them to be equal, but on the other hand they are different type. One is a float, one is integer. Therefore, depending on what you want exactly, so it's very hard to define equality. And especially in Lisp, Common Lisp and Emac Lisp, for example, let me digress a little bit. So for example, in Emac Lisp, you go to Lisp Basics, then you go to XAR Emacs tutorial. Then you have a section on equality, okay, Boolean equality test. So for example, in Lisp, you have many equality testing functions. You have equal, you have EQ, you have EQL, you have the equal sign, you have string equal, then you have char equal, and so it's fairly complicated. Now in Wolfram language, if you search for Wolfram language tutorial, search my name, and you'll find Wolfram language only has 2 equality tests. You can go to Boolean and go to equality test. So one of them is called SameQ. Q means a question. True. So any function whose name ends in a capital Q, that Q stands for question. That means the function will always return either true or false. No other possibility. Either you always return true or false. So that's same Q, and it has a syntax shortcut of triple equal sign. So the same Q will basically test the structure. Because Wolfram language is a symbolic language, everything you see is just a sequence of symbols. There is no actual integer or float. It's just a sequence of symbols. You can think of it as a string. So in Wolfram language, all this source code is just like string, symbolic string. So, it's called terms. That's why it's called term rewriting system. It's called terms in computer science. But anyway, so you got this same Q which tests structure of two things. Then you got this equal function which with the shortcut of double equal sign, and this allows you to test whether 3 is equals to 3.0, things like that. But so you only have these two functions to test equality in Wolfram language. So you might think it's simple, but actually not really, because then you can see some of the quirks. For example, if you have nested list of like 1, then equal one single list of 2, it returns itself. Like it cannot determine whether it's equal or not. And that behavior is because I think it's designed that way because in this term rewriting system, there's a lot of situations you when you cannot be sure. I mean, the bottom line is that it's very hard to define what is equality. So notice this function equal does not end with a capital Q. So it does not always return true or false. It returns true or return false only when this function can absolutely determine it's true or false. So you got this weird situation, empty list equals to 2, yes or no, it cannot say. So it just returns that expression itself. Okay, so that's about equality. Very complex things in programming languages, especially when you have nested list. For example, in Python. Then in Python, then you got the situation. In Python, Ruby, or JavaScript, or almost all languages, you see, when you have nested list, then you have the, whether you are not sure whether you need to compare the content of the elements or the reference of the elements, also known as shallow copy versus deep copy, things like that. So in Python, Ruby, JavaScript, whenever, for example, you want to determine two nested lists are equal or not, you got some issues. Yeah. So anyway, let's get back to these things. So we digressed into about equality test. So this test function, Zagrid says, why is most of YouTube content simply uninformative? Is it impossible to find quality channel? There are quite a few quality channels. You just have to find it. Okay, I think this is kind of boring, and okay. Let's finish writing this. Okay, I'm gonna relax and instead of doing a boring stuff, let me just enjoy myself. I need to do this myself anyway. So say hi of those you Wolfram language coders or interested in this computer science stuff. I'm writing too slow. I mean, this is like, yeah, okay. Anyway, so let's see. So you said the result was kind of like a global. Okay, so they are fine tail that, then test. Okay, then you run this. Okay, so you can see here we have a function, x test function. Okay, now this function is only used once. You see, it's defined here, it's declared there, defined here, and only used once. So we could just remove the just put the function inline, like inline here. Yeah, but anyway, so we run next while, and okay, then once it's done, there's a, we can return the x result, the length of it, if the function is repeating. But if it's not, and yeah, okay, so if the max nest is reached, then the result will, and if it's not still not cyclic, then the x result is going to be empty. So then the length of empty list is 0, so this function returns 0. So I think we got it. Yeah, I think that's it. So save it, close it, reopen it, copy. I think that's the code we want. Okay, I think we got it. Okay, so wait, so it's red here. Oh yeah, so this needs to be a semicolon. Yeah, nice Wolfram language syntax coloring. It caught the error. So before we were using module, that's why. So now it needs to be semicolon. Okay, let me explain the semicolon thing. Okay, so when you have something semicolon, let's say GGGFF any something. Okay, when any of these symbol is any expression, it may be super long or whatever. So when you have anything like that, it automatically, this is the semicolon is just the syntax shortcut. This this will become okay, it will become that. You see, when you have a semicolon and there's nothing after it, then it becomes null. So this becomes that. Or if you don't have a semicolon at the end, then it just becomes that. You see, this becomes that. And you can see that in my tutorial. Search for semicolon. Graphics programming, syntax operators, association, list advanced, okay, data structures, pattern matching, define function, go up, expression, atom head, there, semicolon. So click on that. So it's, you see, it's just a syntax shortcut for compound expression. And this is similar to Lisp's PROGN. Okay, so now let's go back to, let's put this back, let's put some, copy that, so we know we we logged what we talked about. So here's a code, make a backup, color syntax it, let's show, and here's our code today. So we need to test if that works. So it's over here. Did we fix it? Yeah, we did, semicolon. So if, oh yeah, we forgot, wait, this you need a semicolon. Yeah, you do need a semicolon. Length result. Okay, that's nice. That's what you want. That's right. Okay, so let's do copy this again. Copy it. Paste. Run it. Okay. Now if you do we have the mod 5 defined? No. Now we need to test this function. So this should work. How do we find a function that we can test this? Last time we didn't find we didn't find it. We need a function such that when it is nested with a, given an initial value, then when it's nested, the function is periodic. Last time we also determined the periodicity may be dependent on the initial value. But what we didn't have is an example of such function. We need an example of such function to test, to really robustly make sure that our get nest period works. So yeah, so last time we have this hailstone, these hailstone numbers, hailstone sequence. What? Why is this 27? Undo. Oh, you need to paste it here. Okay. So why is this 27 red? Oh, you need three arguments. That's right. Yeah, starting, and you need to, yeah, n times. So next list you need n, let's say 99 times. Okay. So we have this. So 2799. Let's run this. Yeah. So it did not return, let's say 299. Okay, it takes over 100 repetitions to nesting in order to get to 1. So hailstone function, or collapse conjecture function, this function will cycle. It has a periodicy of 3, 4 1 2 4 2 1 4 2 1, periodicy of 3 for basically any input. Okay, so when we use the hailstone function, so we can try to test our function with the hailstone. Okay, so let's try that. Let's try to test our function. So get nest period of the hailstone function, and the initial value of, let's say, 27, and runtime maximum of 1000 times. Okay, now this should return 3. Okay, so let hopefully, did we evaluate yet? We didn't evaluate, so we need to run it. Okay, get next period. Now run this. 3. Beautiful. Okay, I think I solved it. So we didn't test so much yet, but I'm fairly confident it works. Yeah, so let's try the mod. So we haven't defined, so if you define the mod function, did we define the mod function yet? No. Okay, so we need to paste it, shift enter, define it. So for the mod function, the function has a periodicy of 5. It returns 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, repeats. But when you nest this function, the periodicy is just 1. Because when you nest it, basically it, we can try it. So let's try nest list. Okay, so you want to nest the xmod5 function. Okay, and initial value, let's say 30. Okay, let's say 5. Then maximum of 100 times, shift enter. You see, you got 0, 0, 0. Periodicy is 1 because the 0, 0 is repeated, and the unique value in the repetition is just 1 value. So that is why the periodicy of nesting the mod5 function is 1. You can try with different number. Let's say 3. You got the same thing. So if we try our function, to find the period of the xmod5 function, okay, and starting with whatever number, and maximum of 1000 times, it'll return 1. Enter. 1. So correct. So we tested 2 examples. It works. Not a full test, but I'm pretty confident our function works. Okay, so our function, this get nest period, suppose should work. Let's copy this for the record. Yeah, we already did. So the result is 1 there, and here the result is 3. Hailstone numbers. Yeah. So, okay, now this function works. Now we can go back to the original problem of the advent of code. Okay, so let's see, what is this? This belongs to this is about getting the cyclic tail, so we can move it. Cyclic tail. Okay, now put this back, color it, show in browser. I think we have a kind of a stop. So yeah, so the next, so fantastic, this function is what we want. Now let's go back to the original problem, Advent of Code 2023, day 14, part 2. Okay, let's see. So That problem is fairly complicated. Okay, so we got, yeah, okay. Let me look at this one cycle. Okay, so we want to go to take 2 because we have better code. So we have move north, move west, move south, move east. Okay. And we have one cycle, then we have all moved. Then we have list of moves and we did an animation of it. That's fantastic. And we started to try to write this function, find next period. Okay, this is written by someone else. Okay, so this code is written by someone else, so we can actually compare our code with that one. I believe, I'm pretty sure mine is more efficient, faster and okay, so so what we do next, so we want to, yeah, let's continue the advent of code. So we need to, so here is the manipulate. Copy. Okay, let's see. Yep. Okay, so now we paste all the previous thing. Okay, now go to the top, refresh. We got the input, we turn it into matrix, we got row count, and we got column count, which I don't think we need, so delete it. Then we define the function move north, move west, move south, move east, or by pattern matching. Then do them all. F1 cycle is all the movements in one shot. Then all moved is the final let's see, next one cycle matrix. Yeah, so do this 100 times, then total. Okay, but the question is you have to do it 1 billion times. Okay, so do it 1 billion times, find the final board configuration and count the number of boards in each row. For each one, multiply by the inverse of the row number of that row, then add them all together. So that's what this does. But the essence is that you want to find the final board configuration after 1 billion cycles. And we tried that. It's it'll take a long time, so we discovered we need to find the cycle, because after all this ball rolling, there's a cycle. We need to find that cycle. Once you find the cycle, okay, so yeah, so you need to find the periodicy of nesting this function F1 cycle. Okay, so what we can do is we can get periodicy. X get nest periodicy. Okay, get nest period, and of this function, and of initial input is a X matrix, and maximum number of times, let's say this you need to guess, but you can say 1 billion. Okay, 10 raised to 9. But for now, let's just say 3. Let's just say 4. It's not too big. Okay, so this will get the period. So 1 billion times would be, so what you got is mod 1 billion by the period. Okay, so for example, let's say 10 by 3, mod 10 by 3 is 1, right? There's always a off 1 by 1 thing. So let's say mod 5 by 3. Mod by 5 by 3 is 2, right? Let's try it. Right, so it gives you the remainder. Okay, now if you got 1 billion, you need to think about this. So if the period is 3, okay, so you need to so let's see the periodicy. How does it go? So if you have 5, so if you have 1, 2, 3, 4, 5 different board configurations, and but you wanted to do 7 times. Okay, so it's cyclic. Okay. Okay, so you see, it's a bit tricky because this function f1 cycle, it doesn't cycle in the beginning. It may not, it's only after. Wait, does it? Oh, it does cycle from the very beginning. Right, okay, so that makes a lot simpler. You see, the F1 cycle, it does cycle from the very beginning. Almost. I mean, after the first, when you move all the ball to the north, if you consider, you got off by 1 issue here, but if you, so the initial board, let's call it 0 configuration. So the first generation is move all the balls to the north, and wait, I mean the first generation is completing 1 cycle, so all the balls ends up on the east. So and then you got so you want to complete, let's say, 7 cycles. Okay, you want to complete 7 cycles, and 1, 2, 3, 4, 5, 6, 7. So there's this off by 1 issue, kind of tricky, because Fairly complicated problem. So if you have 7, so let's focus, okay? So board configuration. So what does this 1, 2, 3, 4, 5 means? This 1 means after running 1 cycle. 2 means after running 2 cycles. 3, 4, 5, 6, 7. So 7 mod 5 is 2. Okay, so after 7 times, you end up the same board configuration as the second cycle. So you take the remainder, that's right. And what about, yeah, okay, so 1 cycle, 2 cycle, 3. So if the board has a periodicy of 5, if this F1 cycle function, then that means does it begin with, yes, it begin because the first cycle will move all the balls north, west, south, east. So once you tilt it, it's kind of all like flushed out. So after the first cycle, then you go into the second cycle. Yeah, so if you know, if the F1 is periodic when you nest it, then the cycle will begin in the first generation, meaning that if the tail, you know, if there are 5 board different configurations, they repeat. It means the entire result is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You know, it repeats from the very beginning. Okay, so if you want to do 9 billion, I mean 1 billion times, so you just take that number divided by the number, the periodicy of nesting, then you got the remainder. The remainder is just the index of your cycle, starting with cycle 1, indexed 1 based. Okay, so you just take the remainder, so it's clear. So you just mod 1 billion by the period, that's the remainder. Then you just cycle it that many times, okay? So don't do that. So basically you want to do that, this, okay? This is all moved. So you nest F1, initial value of the matrix, and how many times to nest? You take the remainder of the billion, remainder of the billion divided by the period, okay? Yeah. Okay, now what about the period? What is the maximum number of tries you want to do? That depends on the board size, okay? I mean, what is the maximum upper bound for the periodicy of the cycle function? Well, that depends on the board size and the number of balls and the number of walls. So, yes. So, and mostly it depends on the number of walls. But in general, yeah, in general it cannot be too large. I don't think it'll even be more than 100. So this becomes another pure math problem. So the problem is to determine what is, you know, given a board like that, or do we have a, no, we don't have the, you know, given a board like that, and we could have a bigger board, for example, here, you know, this user input. So this is, I think, 100 by 100. So given a board, you want to determine what is the upper bound, what is the maximal possible periodicy of this F1 cycle. So it will be, I think it will be less than, it will be for sure less than the width times the height of the matrix. That's still a lot. So if the matrix is 100, let's say it's 10 by 10, the cycle is less than 100. If the matrix is 100 by 100, the cycle is less than 10,000. That's right. But that's still too much of an upper bound. I think it's significantly smaller, because then you also have to count, so the cycle is like the upper bound is pretty small. So now knowing that, we can kind of get an idea what we want to put here. So we know our initial board is like 100 by 100. Okay, so yeah, that's a good number actually. Okay, so I think that's it. We can run the whole thing. That this should give us an answer. Let's hope so. Okay. So where is our function? We So we need to clean this. Okay. So number of cycles. Delete that. Let's delete that. Okay. Board history. Delete. Okay. Delete. Okay, delete, manipulate, tally, delete, find next period. That's what we want. But last time we failed, so now let's just delete them. Okay, we need to move this up. Because we use the function. Actually, the function we need is just this find cycle, and okay, let's copy it. Okay, so let's put this part at the bottom. Okay, move to the bottom, paste it there. Okay, select all, let's just run it. One last double check. Okay, so we mod hailstone and find cyclic tail, then get next period. That's the important function. Then starting the advent of code problem. Okay, let's run it. So wait, here. So get period. Okay, then all moved, so then total, run it. 64, I think that's the right answer. Finally, this took 3 days. Okay, so it says 64, and now it wants my own puzzle input. Okay, so let's try my own puzzle input. copy. So this is what you want. Cut, close. Okay, copy all. Paste. Right. What? 3? Wait, what? Oh, it's still running. Wait. Come on. Did we? Okay, this doesn't look good. It's still running. Shift Control Escape. Let's see if it's using 1 gigabyte of memory. Okay. Okay, so find cyclic tail if match. This is taking too long. Not good. God. Okay, maybe we can do some cleanup. not looking good. Okay, while it is running, why don't we clean up the code? That's right. Why don't we? Yeah, let me just clean up the code. Okay, so I want to first of all make this just to be that. Okay, and without the advent of code. Okay, so that is one part. Then this part will be just for the advent of code. So you don't need these test functions. Remove all the thought process. Remove hailstone. Remove the algorithm description. That's what you need. And remove example. Also remove the algo description. Here's another function you need. In fact, this function, you don't need separate functions. Yeah, but it gets complicated. You see, here's a function and it's only used here one time. So technically you don't need them to be separate. You can just inline the function here. Okay, but so anyway, remove that. So here's the input. Now the input, if you tried it, you see this is still running, so that means it's not good. Something is wrong. So, but the last time the result is 64, that checks out. But why is it with the user input something is wrong? I don't know. Yeah, fuck. It's really nasty. So now the input, now you will count, move north, move south, and run cycle. So why is it wrong? Period. Now let's search for the period. The period, you get the next period. So how do you determine the equality? Let's go back here. Next while, the test function, okay, if result equals to is empty, then true. Oh, okay, so head, tail, tail. So it's possible that this function is incorrect because this works for a flat list, but if you have a matrix list of lists, yeah. God, so you need to test this function. You need to be sure this function works. You see, what we need to test is that if you have a flat list such as 2 3 1 something something 2 3 1, then it works. But let's say your list, let's just say 1 2 2 1 2 1, okay, let's just say 2 1 2 1. Now, but if your list is nested, okay, like 2 1 2 1 2 1 2 1, let's say 2 1 2 2 3, okay. So in this case, this is not a cyclic list, but however this pattern matching, this head tail might just match this sub expression. So therefore it returns 2 1 2 1, but it's actually not. So maybe, so actually, yeah. So if it match, yeah, so actually all we have to do to test this hypothesis is just run this, okay. So we can run it here. This is independent. So it says false. Oh yeah, so it matches the whole expression, so that should work. But then, hold on a second. So yeah, okay, so that worked. That's good. And what about this part? Okay, so what if you do that? Okay, let's try it. This is incorrect. Wait, this is correct. Okay. Yeah, so it didn't change anything. So this should be correct. So what if we run this find cyclic tail? Okay. Should be. This should return empty. Okay, if we run this thing, it should return empty. Okay, let's try it. Yep, it returned empty there. So you need to put semicolon there so that it doesn't, it doesn't print this usage string. So this return empty, that's correct. And yeah, but however our program is still running, so that's incorrect. I don't know what's going on. And remove this test code. Okay, this test code, remove. Okay, now let's copy all. Let's stop this alt period, abort it. Okay, now select all, and paste with our new code. Okay, so paste our new code. So the input, so you see when the input's small, it works. Shift enter. Oh, that's why this thing, you know, we don't have the semicolon, so it's generating a huge output there. Yeah, possibly. When you generate a huge output, it can be very slow. Okay, you don't want to show that. So okay, so go to the top, select all, paste, actually select all, copy, copy all, select all, paste. Let's break them into sections. Okay, so the above is all the definition. Shift enter, run it, then period. Now let's say 3. Can you have a period? Period 7. So this period is 7 for this small board, for this small input. So period is 7. Okay, it's good to know. Then Shift Control D, split that, run this. This is a final board configuration. Then Shift enter, total is 64. Okay, but now if we try this user input, okay, now this, we try this user input. Okay, that's good, that's good, that's good. Go down. Okay, Shift enter. Okay, now let's be careful. Let's see what is a period. Will it run forever? No, it should stop at least 100 times. So it should stop, in it, no more than 20 seconds, because we are trying to find the next period of the F1 cycle function, nesting it no more than 1000 times. So the time we'll take is no more than nesting F1 cycle 1000 times. Now, this matrix is just 100 by 100, so it shouldn't take that long. Okay. Okay, this video is bad. Nobody's watching. Yeah, we got a problem. Yeah, it's so bad. Shit. This F1 cycle nesting's got a problem. So So where is our problem? Next while. Okay, next while. Let's see in the test function. I'm not seeing why should there be a problem. X get next is period. I don't know. Alt period to stop it. Now close Wolfram language. Let's start from the ground up. Okay, so yeah, so tilings close, don't save. Next is close, tilings don't save, and net close. Okay, let's start afresh. Maybe, possibly, we have some, some trash in our memory. So Control N to open a new, enter 3, then Shift Enter to evaluate it, magnify. Now copy all, paste, and now go to the top. Okay, now actually we want to this input, okay, then remove that, copy all, select all, paste. Now let's go this is our code. Now let's split here, evaluate all the functions and input. Now split. Okay, now let's test period maximum of 10. Okay, let's see, that should return something. Come on, max of 10 times. Okay, that's not returning. That means something is wrong. Something is wrong with the get next period. Okay, so maxed next list, why is it? So did we get next while incorrect or something? Yeah, so that is wrong there. Just 10 times. Why can't you stop just 10 times? Yeah, we need to debug. Still present. Zagrid. Solving problems others wish not to is a reliable method of learning. Yeah. Okay, so today's talk show is no good because, well, when you do a YouTube, it's a good video if it's interesting all the way, but today we struggled. Most of the time it's like just nothing, no result to show, no aha moments. It's kind of boring for an hour, for now 2 hours. So it's not good. Maybe I should delete it. Hello, Rodolph. Nonsense. Okay, so Yeah, but as far as coding, real life coding is just like this. Like usually half a day, you just sit by yourself and scratch your heads. But I'm not happy because I've been coding. Like this advent of code, I should be considered trivial. I've been coding for so many years, and now, it's not going anywhere. So anyway, so to solve this, I don't really want to. So right now we just stuck on this get nest period. It's not stopping. That means something is wrong, okay? And we look at our code, the maximum nesting, is only 10, but it's still running, so something is wrong. So we need to debug this, okay? You can add a print statement, but why is it even just for 10 things? Okay, so let's stop it. Alt period. So what you're gonna debug? So you're gonna print. Let's do this. Let's every time you call the test function, you're gonna print it out, okay? So every time the test function is called, then you print. Okay, wait. Yeah. So you print the result, you print that. So every time this test is called, you print the result. So it's just gonna print a lot though. Well, yeah, but okay, so you need to, let's try this definition. You're gonna solve this step by step, okay? Done. Now we go back here. Instead of max times 10, let's just say 3. Okay, because potentially it's gonna do a lot of things. Okay, shift, let's say 3. Okay, shift enter. It's not even printing. Okay, something else is wrong. Did we get the syntax right? F1 cycle matrix 3. Something, okay, something is totally wrong. Wait, but for the small input it works. Okay, something is wrong. I don't know. Alt period to stop it. Maybe something really silly. Okay, Shift Control D to split this, and now let's make this run. Okay, let's nest 10 times. Shift Enter, do it. So F1 cycle 10 times. Come on, 10 times is so small. It's stuck. Okay, Alt period, stop it. Let's say 1 time. Just what the fuck is going on? Shift Enter. So even 1 time is stuck. Stop. Okay, something wrong with your F1 cycle. Okay, let's just try the F1 cycle. Before we do that, comment this out. Okay. Can you actually, do we actually have the X matrix well defined? Shift Enter. Yeah, that is right. Okay, it's a big one. No problem. Okay, we have the matrix defined. Then F1 cycle matrix, right? F1 cycle means row northwest, southeast. Shift enter. Okay, here's a problem. Even running one cycle, it's like stuck. Wow. Wow. That means our pattern matching code is shit. So we got a fundamental problem. Our pattern matching code. What? This is really embarrassing. Even running one cycle, you see the F1 cycle is defined to be a function that you just apply, move north, move west, move south, move east. Very simple. But now, even running just one cycle is taking more than 10 or 20 seconds. So a problem. We got problems. So that's not good. So Alt period to stop it. Yeah, so next step to debug is, let's call the move west. You know, I cannot believe, I don't believe it, that, you know, even the move, a simple move is got a problem. So let's say matrix, shift enter, move west. Okay, it's stuck. Okay, now I feel better, because if this function is stuck, that means the problem is not my code. It must be we forgot to, like, we forgot to, like, wait, can this actually take that long for pattern matching? Wow, I can't just believe it. Okay, we don't know. Let's say, what is our matrix? Right? So, okay, that's the matrix. Dimensions, (100 by 100), correct? Okay, now let's see what exactly is the items. Okay, let's magnify. Okay, now take the first element, shift enter. Okay, that's the first row. Now Control L, then you take the first element, then take the first element. Okay, that's a pound sign. That should be a string. Okay, and okay, then you query postfix notation by the function string q. Okay, you ask if it's a string. Yes. Okay, so that means the first row, the first element of the first row, this pound sign, is a string. Correct. Now, what about the first row, but the second element, the dot, it's also a string? Control Shift, let's see it. Shift enter, yes. So we do have a matrix. This is 100 by 100 matrix, and each element is a string. Check. So far so good. Yes, but this move west function is failing a simple function such a, you know, this simple function is, let's say, question mark, enter. There it is, our function, a simple function is failing on this matrix. Cannot possibly be. Let's try. Okay, shift enter. Now how can this be? This matrix is just 100 by 100, and this pattern, now it's possible, you see, because pattern matching, the Wolfram language is so powerful such that you can easily get into combinatorial exponential issues. But in our case, we just have a head on a 100 by 100 matrix. I don't think so. You see, even this move west, it's not returning now. This means all the past days we tried all this, this elegant solution. It's not working, even for just 100 by 100 matrix. So this is very discouraging and embarrassment. Godson Law talk show. What? Nonsense talk show. Okay, Law, most unfortunate. Yeah, so you see, he's still not returning. We got something really, really basic that's wrong. So right now we don't know why, but our function move west, it was working before. Okay, let's try. Okay, let's stop this. Now if we redefine the matrix to be the small one again, okay, copy it, redefine the matrix to be just a small one, shift enter. Okay, then we need to turn it into a matrix. Okay, so here's a code, turn it into a matrix. Do it, shift enter. Okay, got a matrix. Now we do this move again, move west, shift enter. The result is instantaneous. Oh God! So what is the problem? Is it possible I have a typo somewhere? No. Okay. So wait. It's all capital O and right? Did we? It seems all good. So is there a sheer possibility that, something we haven't considered, when you move all the O to the left, you run into an infinite recursion? That is why, that's also very likely. So that is why your pattern matching, our pattern matching is possibly running into a infinite recursion, because we are saying replace repeated. Shit. But we move to the left. Why should it be? Oh God! In the beginning we have 0 or more head. That must be. That must be the problem. So you got you call replace repeated, start by a head 0 or more items, then you have a pattern of all dots, then you have a pattern of all zeros or O's, and then you replace. Okay, so when you have this pattern, when the beginning is 0 or more, okay, 0 or more, okay, no, it's too bad, we run into this problem. So for this problem, yeah, we run into this very basic problem, but it's also a clear problem by itself, simple independent problem. With this matrix, just 100 by 100, our function move west is not working. It's taking forever. And the reason is likely this replace repeated, this pattern is just repeats forever. But why is that? Pattern. So this pattern is 1 or more, not 0 or more. So 1 or more dot followed by 1 or more O. Okay, so at least there's always 1 dot followed by 1 O. When you found that, you swap them. Okay, that's the move west. Okay, so yeah, and then okay, so whatever head is 0 or more items. Okay, so let's look at one example. This is a long row, 100 items. So you swap. So eventually, every time you swap, eventually you'll find that it's no longer the case. You have a situation where you have at least 1 dot followed by 1 0. Right? Because you swap them all. So it should not be infinite. I don't understand. But let's, maybe I'm wrong. So let's maybe try. Let's redefine this. This is a very nasty problem. So if we redefine our function to be so right now what is our matrix? Matrix dimension, shift enter, so 10 10. Now let's get back this okay, so you need to get back the matrix. Okay, so let's get the matrix. Let's put the input here. This is one input. Then the second input, this is the user input. Okay, so if we evaluate that, so that's the user input, then turn into a matrix and that. Okay, paste. Okay, then now let's check our matrix, run it. That's too big. Okay, cut, delete. So let's just check the dimension, 100 by 100. Okay, and remove that. We have already checked these, so we don't need to check them. So we now got the 100 by 100 matrix. Now we want to move west. Okay, and okay, so hold on a second. Let's cut that. Let's paste it here. Define the function move west. Okay, shift enter. Now if we run this, it will run forever. Shift enter. Yeah, it runs forever. Okay, meanwhile let's clean up this and let's clean up this. Okay, it runs forever, no good. So alt period to stop it. Now let's change the definition of this so that maybe we find out what possibly maybe there's something wrong. So we are, instead of longest, let's don't do the longest. Okay, remove the longest. Okay, so copy that, paste it. Now evaluate this part. So now it's a new function, different, move west. Now let's run the move west. Shift enter. Okay, I think something is wrong. Rather disappointing, because you see, so right now we narrowed down to a very clean problem. This function is not correct for some reason, because it's running forever. So it's running forever likely means this replace repeated is running forever. So that, but it should not, because when you have a board, you simply move all the O to the left, nothing else. You simply move all the O to the left. Okay, so so the problem should not repeat forever. So unless maybe our pattern, for some reason, this pattern 0 or more, it changes to that dots and balls. Dots and balls, balls and dots. So it shouldn't repeat forever. There's no way. There is no way. So very interesting, so we have a hard clash, because this problem now is so simple. This matrix is not too big, only 100 by 100. Because in real life, you might have like 1,000 or a million rows. So, but I don't think this pattern repeats forever, but that's what we get. So next step is actually just start to look at this pattern. Yeah, very annoying. Okay, alt dot to cancel it. So next step is, we just look at the pattern itself. So new Wolfram language code. I want to take a break. Okay, so anyway, new Wolfram language code, move south, move east, so move west. What? Okay, copy that, put this back, go here, close that, go here, paste. Okay, Now, instead of a function, let's simply try the pattern. Okay, delete that, delete that. So here's the heart of the function, replace repeated. So in fact, we just say replace all, don't repeat. Once we do it one step at a time. Okay, so this way, tell me what possibly, where does it go wrong? So we can actually see it. This is to the replacement one step at a time. Okay, cannot possibly go wrong. This pattern matching, we start with the matrix, we replace all of this pattern by this. Okay, shift enter, you cannot possibly go wrong. Now this is one single replacement. Okay, it returns, but it takes a long time. So that means, okay, I think maybe I need, yeah, good. So let's try to do some improvements. Okay, 0 or more, let's say, perhaps this head is the problem. So let's look at our matrix, the first row. Okay, the first row is pound dot 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 pound dot 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 O. Okay, now go back to the new result. Our result pound dot 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 pound dot 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 O. What? No change. What? Pound dot 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 pound dot 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 O. What the fuck is this? Pound dot 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 pound dot 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 O. Okay, but it so seems like it didn't change anything at all. I don't understand. So now let's try just the first row. Okay, so let's try this. Now X matrix, the first row. Okay, let's have a look. That's that. Now let's move west, the first row only. Do it. Takes a while. You see, it worked. Wait, pound dot 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 pound O. So it worked, but however, you see, however, if you do not specify the first element, but after you did that, then you say you want the first row, shift enter, do it, then it takes long time. This is a problem. So the problem is indeed our pattern. Our pattern is very inefficient. So that is, that is actually the, a major issue when you use pattern matching in Wolfram language, because it's hard to determine when your pattern is efficient or not. You see this move west one single time. Wait, we don't want to move west. Yeah, well, anyway, so the move west one single times takes forever. Now I kind of know why, because you are doing okay, so this is even taking forever. So what you want to do is that you don't want to replace all. Okay, so yeah, God, I think I need to stop. Okay, failed today. I think I'm gonna stop. Failed today. Then I'm gonna delete the video. Okay. Bad video. I mean, otherwise you have so many solid videos that's just too long and boring. Okay. So thank you guys for watching. I'm gonna delete the video, and this is actually an interesting problem, and in fact it's right now it becomes a very interesting technicality about pattern matching in Wolfram language, because we have narrowed down to using pattern matching on this, and we run into the efficiency issues. Even running a single time, you see, by now it's taking like, and even just move all the balls to the west, it's taking like probably exponentially. Hard to imagine though. I mean, that this is a surprise. It came up for the episode. Thank you for the episode. Yeah, thank you. Where you from? Zagreb. Are you Wolfram coder, or are you just interested in programming in general? Yeah. So if you want to answer, let me know. Oh, it came out. So it takes a long time. You see, it takes like 30 seconds, 1 minute. It takes 1 minute simply to move all the zeros to the left of a 100 by 100 matrix. It takes a minute, like almost 100 seconds. So, but it did come out with a result. So it means our algorithm is very inefficient with this pattern matching. Okay, this pattern, this repeated. So how to fix that? I know. I mean, I do have some ideas. I have some intuition about what part to change, because okay, there are like three things I need to go into. Okay, so one, first of all, is that you want to try to not use replace repeated. Rather, you want a pattern that does it in one shot. It moves all to the left. Okay, just one shot. No need to repeat and test if it's still come out different. So it is possible. Okay, I think I'm 99% sure that it is possible to remove this replace repeated. Instead, you just add like 2 or 3 more patterns. Okay, so that's one thing that will significantly reduce the speed, increase the efficiency. Now the other thing is that when we use this pattern, this head something 0 or more, then any dots, then any balls, then tail. This pattern is meant to match a row, okay? But however, when you use replace all, or when you use replace repeated, it will try to match this pattern with respect to the entire matrix, 100 row by 100 columns. So instead you want to either introduce a pattern, like either introduce a pattern, or you use a map, a pattern to all the rows. So that can possibly reduce the inefficiency, because otherwise Wolfram language just try all the possibilities. Yeah, so anyway, so that's two things we can possibly fix. The other thing is that I could try to remove this 0 or more, because whenever you have 0 or more items, that's potentially exponential in time, because 0 or more means you'll start to try with 0 items, then you'll try with 1 item, then you'll try with 2 items, until the n items in a row. So you want to avoid this 0 or more pattern. So in order to avoid that, you could have a pattern where, use a pattern where you contains the pound sign, because all the dots and O to the left of them needs to be a pound sign, okay, either a pound sign or the beginning of the row. So you put a pound sign here instead of the head somewhere, okay? That will possibly reduce, yeah, it will, I know for sure. So anyway, interesting. Okay, bye guys. I need to increase my mathematical capabilities. Love today's video. Struggle upon struggle, just like in real life, the exact opposite of canned YouTube explainers. Okay, should I keep this video? Because I'm thinking of deleting it. Maybe not, because that's real life, So what do you think? Let me know, or let me know in comments. Okay, so anyway, so we're gonna say goodbye. So we stuck, bad video. Okay, very interesting. Bye guys. Keep it. Okay, fantastic.